algorithm, you're basing it on historical data, and you might, and it shows you things that based on history that you might not want, that might not be the thing that you're looking for, right? So let me give you an example. Great segue to my next slide. And then you might say, well, this shouldn't matter, right? Because you've trained it on historical data. And like, fine, like we understand why, you know, he is to computer programmers, she's to homemaker. Before that, you were going to ask a question or say something.
I was just going to jump on. I was actually going to say what you said. Like when we first used the word computer, it was to refer to almost all women. So historically, that was a huge shift that happened. It's not reflected in the data.
Yeah. So
it became more lucrative.
So Mar Hicks is a historian. Mar Hicks is a historian who wrote a book about this, actually, for anybody who's interested, but only in the UK, in the United Kingdom context. But so here's a question. So you might, let's go back to higher view. I'm not saying they do, but I'm just or LinkedIn or whatever. Let's just like find, you know, like a company that analyzes resumes, right? So you can imagine you might want to use word embeddings to find keywords and resumes that are close to other keywords. So let's say I want to find, you know, some keyword that's like a close to programmer. So Java, Python, programming, C++, blah, 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 would be close to programmer, right? But then let's say there's also other things like quarterback, University of Vermont, et cetera, et cetera. And then that tells you this probably is white male because University of Vermont, mostly white, quarterback is men, right? We don't have women who play football. No reason why they shouldn't, in my opinion, but anyway, that's a different story. And then you have another resume, which is exactly the same thing. You have Java, Python, C++, blah, blah, blah. And then Spelman. Spelman is a historically black college. And then you have a softball team captain, and that tells you it's you know, probably a black woman. And now what you would have if you train this analogy detector, which I mean they show in Adam Kalai and his collaborators there in that paper, is that if you now have the distance between the two programmer, between keywords in this resume, that is much farther than the distance to programmer between keywords in the other resume, right? Because you've encoded these societal biases, then you use automated tools to figure out who is appropriate for your job, then you're discriminating against people, right, based on their gender or color or whatever. And this is just historical stuff we know of. We might even introduce new discriminations that we didn't even have historically because of maybe the type of training data that you're using, right? So this is a kind of, so you have these little systems, like word embedding might seem insignificant, but as you string them together and are making really high stakes decisions on whether someone can get a job or not, then it can create problems that you might not even think it could create. Does that make sense?
But
yeah.
Isn't this basically a problem at the root of like data selection for what you use for training the model? Like, shouldn't it be solved? It's not like a limitation of the model, right? It's basically bad design.
Yeah. So in this case, it's not necessarily a limitation of the model. Possibly, we don't even know what the model is. Like, that's the one other point I'm trying to make, is that you have these models doing things that are affecting people's lives, and they're not required to tell us anything about their models, which we'll talk about later. But yes, so again, so if you take Jamie's class, which I'll be an advertisement for her, there are, you know, different ways to think about this problem. One is, sure, your data set now should be representative of people, which is a great segue because I will talk about that as an example. Two is your metrics of classification accuracy or whatever maybe should encode some notion of fairness. What does fairness mean? This is a whole other thing. And that part I won't talk too much about. Today I'll talk more about the data, right? And yeah. Okay, any more questions? Cool. We're at 20 minutes, guys. Okay, so another example that was highly publicized is this Google Photos, I don't know if you guys have heard about this, classifying black people as gorillas. So one point I want to make is the types of errors you make and the application that you're going to use things for matters, right? So for example, if your translation system is making really bad errors on Arabic, and you're using it to surveil people who speak Arabic, that relationship matters, right? Again, if your face recognition system or whatever has errors, I mean, this is just one example of an error. I'll talk more about other examples. And you're using it to surveil primarily people of color, and your error rates are systematically they're more biased in against people of color, then that matters, right? Because it's a double whammy, because you're making mistakes on certain groups of people, but then you're also using it more on certain groups of people. This is also another reference that Joy pointed me to. It's called the Perpetual Lineup Report. And I recommend people read it, because they talk about in the United States how 1 in 2 American adults is in a law enforcement database, right? So I'm probably in some database. You might be, I don't know. And they can look you up whenever. They can use it for whatever, right? Now, research that I'm involved in, along with Joy, shows that so what we did is we wanted to see commercial face recognition systems. It's not a training system, so you can't tell me, oh, just change the data set or just fine-tune the model. Can't tell me that, because I just pay for this service. I use it on some, let's say my smartphone or some other, I'm like a startup, let's say, and I'm using it to do something. I pay for this API, and I just use it, right? And so all I have is what that API does, what documentation they give me, what guidelines they give me. And this whole research started because Joy who was an undergrad at Georgia Tech, by the way, was doing, she was just going about her business, taking an art class, and she was like, oh, what would be cool is if I could use an open source, OpenCV face detection system, and I can use it to paint walls or whatever. I don't know what she was thinking. And she kept on figuring it, trying to have this thing detect her face, and it wouldn't detect her face. And she's like, get her roommate, detects her roommate. Tries it, doesn't, detect. Gets some other people, detects them. She's like, And then she puts on a white mask, detects her face. Takes off the white mask, does not detect her face. So then we decided, okay, so she started doing this systematic study, right? It's if we want to see how widespread of a problem this is, we don't want to use just research work or anything. We just want to see, off of the commercial APIs out there, is this a systematic error, right? So we chose something very, very simple, which is gender classification. Now, there's a question of whether you should even be doing that. But so this one was just they had binary classifications. They didn't take into account any sort of other gender identities. They would just say male, female. So you show this API a face, and it tells you whether it's male or female. And what we found is that the darker and darker the skin tone, the higher and higher the error rates, right? So the darkest skin tone, you have, let's see, for IBM it's 46%, for Face++ 46%, for Microsoft 25%. Remember, random chance is 50% here, right? So how did we do this analysis? The first thing we wanted to do is we wanted to just be hey, let's look at existing data sets. No, he can ask a question. It's okay.
What is type 1, type 6?
Yeah, I'm going to explain that to you. It's okay. You guys can ask questions. I thought you were pushing. I saw someone pushing your hand down when you. Oh, we're allowed. Anyways, so how did we? I'll talk about your type 1. So what we wanted to do was we wanted to look at existing data sets and say, hey, let's look at existing data sets. Let's what we wanted to see is how this does by skin tone and gender, the combination of skin tone and gender. So let's first label them by skin tone and by gender, and then we will do this analysis. But we saw that even though so many people have been working on face recognition for so long, all of the existing data sets were overwhelmingly male and overwhelmingly lighter skinned. And so, and then we found ones that were female, but even the ones that, almost half female, they were like still lighter skinned. So we had to have a more like diverse data set in order to do our analysis. So I'm about to talk all about data now, because what was your name? You asked a question about data. So it's all about data. So the first thing is, you have to think about how people collect data sets. A lot of us envision machine learning, or maybe it's just me, I hate collecting data sets. This is like, I spent my entire PhD getting data sets, and is the thing that takes the most amount of time, but it's painful, right? So what we do is we try to get like the data sets that are most easily available. Use Google search, Celeb A has like celebrities or whatever. We generally don't do very much analysis on the data sets we use. And we generally don't think about the use cases of the models that we train on whatever data set. So in this case, we tried to, first thing we had to do is collect a new data set. So what Joy did was she looked up which countries have a high representation of women in parliament. So we looked. We took countries in Africa and countries in Scandinavia, and to get two extremes of the skin tone, right? So many countries in Africa, like your skin tone the variation is really high. So let me talk about this. Why didn't we use race, right? Because classification of race is very weird. Like, it's very unstable across time and space. What people consider black, here versus a Latino or whatever is different, or versus white or Asian, whatever, is different in different places. You can have, certain skin tone characteristics and be the same skin tone and be considered different races, et cetera, et cetera. So we wanted to have a more objective measure of differences, right? So we found the countries with the most number of women, highest representation of women in their parliaments, and we got different countries in different spectrums of the skin tone. So you were asking about what it means for what's the type 1, type 2, type 6 means. So we used this thing called the Fitzpatrick skin type classification system. So they use it dermatologists use it when they're trying to figure out people's risk of getting cancer. So there's 6 bins, and there's type 1, 2, 3, 4, 5, 6. Now, there's even issues with this classification system, because type 1 to 3 is reserved for people we consider to be like European descent, right? And everybody else in the world is type 4, 5, or 6, right? So, but you have to start somewhere. So we started with this classification system. So, so what do? We were like, okay, let's look at the overall accuracy of gender classification systems of these different companies, and when we look on our data set, when we look at it overall, 93%, 90%, 87% sounds great. Let's ship it. We're kind of done, right? That's pretty great, pretty good accuracy, maybe. But then we're like, okay, let's look at it by gender. Now you look at, okay, on female faces, there's like, you start to see a gap, right? Like, okay, 97%, 99%, almost perfect on male faces, and then on female faces, like 78%. And then we're like, okay, let's look at by race. I'm sorry, race, I should not say race, because it's not by race. I explained exactly why. It's by skin type. Okay, please correct me if I say that again. Then you see, like, by skin type, you start to see gaps again, right? Errors, so like here, 87% of darker faces versus 99%, 77% versus 96%. Then we're like, okay, let's now break it down by gender and skin type, right? So in all of these cases, the lowest accuracy were on darker skinned females. And then again here, you look at, so that's for Microsoft. You look at Face++, 65.5%, right? You look at IBM. Now, after this paper came out, they have all, definitely Microsoft and IBM have improved their gender classification systems. They wrote all like press, stuff about it and stuff, like, so that's great. And this I credit to Joy because when we were writing papers, she was like, we should, send an early version of the results redacted with other company names to all of them to give them time to improve it before we publish the paper. Things like this, right? So, so now there's been a lot of improvements, but this is just kind of to show the existence of the problem. Because there's a lot of improvements, but you can imagine how these kinds of issues extend to other problems. So what are some of the key lessons? One is that intersectionality matters. Now we're going to talk about, things of ideas from critical race theory. So I love this example because I saw it on a TED Talk by the woman who coined the term intersectionality and started it. So this example is from, 1977. There was a class action lawsuit, or I don't know if it was a class action lawsuit, but 5 or 6 people were suing General Motors, saying they discriminated against black women. Their hiring practices discriminated against black women. And then the judges were like, okay, so they hire a lot of black people and they hire a lot of women. So you cannot be discriminating against black women. But then when you saw what they were doing at the time, they hired women for secretarial positions, right? And they wouldn't hire black women for secretarial positions. And then they hired women for secretarial positions, but they wouldn't hire black people, period, for secretarial positions. And then they hired men for factory jobs, so they would hire black men for factory jobs, but they wouldn't hire women for factory jobs, right? So if you're a black woman, you're screwed. You're not going to get a secretarial job, you're not going to get a factory job. So you were being discriminated against. But if you only looked at gender and you only looked at race, you would just say no. It's, this doesn't exist. So you had to look at the intersection of these things. So when we're using machine learning systems to affect all of these different people's lives in different manners, we have to look at intersections of things. Now this starts to get complicated very quickly, right? So in order for the example that I showed you earlier, like people test things out, but they have data. You want to make your data set representative, right? So you want to test on, I don't know, short women under 40 with a fro who have glasses and who are like this and wearing scarves. It starts to get pretty complicated. And this is where I think that we should think of different models now, because I shouldn't have to see every representation of every person to come out with an accurate model. Okay. Another key lesson about data is that we should think about where we get our data sets from, who's represented, and who's not represented, right, when we're doing research. And another lesson, I think, for me, is that we can't ignore social and structural problems when we're working on any of our technical fields, right? Machine learning or computer vision or robotics or reinforcement, whatever we're working on. We can't ignore it. And you read this paper with me, right? But yeah. So I love this paper. It's called The Moral Character of Cryptographic Work. And this professor at UC Davis wrote it. It's a long paper, but it touches on cryptography later. But it basically talks about how cryptography has sanitized just like any politics or structural issues or whatever. It's always like, well, Alice and Bob are going to send a message. Alice sends it to Bob and some adversary here, right? But he was talking about how, like, if you were to think about the social structural problems, the ways in which who is usually surveilling who and things like this, then you would maybe come up with different solutions. And so he goes through different things like, let's say, differential privacy and other things, and describes their flaws, if you were to put it in this context. And he talks about, physicists and how they, the nuclear disarmament, the move toward nuclear disarmament happened, things like this. So I recommend this book. I mean, this paper, which might as well be a book. But it's a fast read. And again, so, in terms of social and structural problems in the US, we kind of need to be educated, right? We need to be educated if two people commit the same crime, who's more likely to be arrested and why? Which neighborhoods are heavily policed and why? Because in the US, for example, the people who are heavily policed look like this. Right now, this last year a lot has happened, right? So you have, people at Amazon working on face recognition to sell to law enforcement, and the whole Project Maven thing that was going on at Google. And then you have to think about who is creating these products, right? There is really very little intersection between the people the products are being used on, some of these surveillance products, and the people who are creating them, right? If I'm talking about a high error rate on black women, I don't see any black women there. I also don't see any women, actually. It's like a Where's Waldo of deep learning. Like, I can't spot one. But my point being that, the paper on gender, this face recognition paper that I just discussed, it would not have happened if Joy was not in the field. I don't know if it would have. Because even I'm not a very dark-skinned woman, right? So I wasn't thinking of these kinds of problems. But because this didn't work on her, and she has a context on the social and structural issues in the country, etc. That's why a lot of people are now thinking about these issues. So I think we should think about, all of these things are interrelated, is what I'm trying to say. Another key lesson here is that think about HireVue or any of these other companies. There's like no law that says, who can use our data sets and APIs for what reason. You have the Food and Drug Administration, right? So before somebody unleashes like a new food or a drug or whatever into the country, there's a group of people who test it out, look at the side effects, see if it's if it's recommended to be used in a particular way, etc. We don't have any of that for data sets and and models, etc. Right now, we're just using it for anything, regardless of how high stakes the scenarios are, to get a job, to see if you should go to prison for how long or not, etc. And some laws, some algorithms, you might break the Equal Employment Opportunity Act or something like that. That says you shouldn't discriminate by certain categories, right? You don't even know. You might not. You don't want to, but you might be breaking existing laws with the various models you have right now. Not you, but I'm saying we collectively. So I will always advocate for standards, documentation, regulation, and so I want to close by saying some other industries have been there, right? There are more mature industries that have been there. So, for example, I come from the hardware background. I used to be a circuit designer, and in circuits, when I came to see like what happens in our research or in our field, I was so shocked because in circuits, when I'm designing a circuit I used to work at Apple, into like some system, I was very well acquainted with a data sheet for each circuit, for each component. It doesn't matter, are there any hardware people here? Yeah, so it doesn't matter how simple it is. It could be a resistor, it costs like 1 cent. It could be a CPU, whatever. Everything comes with a data sheet. So when I'm looking for a product, I go to it. Here's the data sheet right there. That's the website. And the data sheet tells you many things. Like it tells, it's all tests, what happens, non-idealities across temperature. Like when you model a resistor, for example, there's like an ideal model, but that's never the case. What happens under different scenarios. Also, let's say take it, even something as simple as a resistor. A resistor to be used for railway applications needs to have really different tolerances and characteristics than for like some toy or whatever, right? So take face recognition, you know? It's the same face recognition thing, but if you're gonna use it to say someone is a criminal versus not, versus some like playground thing, I don't know, it should have very different characteristics, right? And I should be able to know whether when I'm using your model, like whether it's appropriate for a given task. So for data sheets here, I think so. I think we need data sheets for data sets, pre-trained models, etc. And I think that again we need to have information regarding standard operating characteristics, recommended usage, how did you gather the data. For example, it's okay, maybe you want to just use a model for people under 10 years old, right? So then if you have if the data set you're releasing that it was trained on was just for people under 10 years old, that's totally fine. But I just need to know that I shouldn't use this model on people who are over 80 years old, right? Like I need to have some of these guidelines. And right now we have 0. And so, and also like when you look at these gender classification APIs, the first thing I notice is there's 0 information. For example, when you look at when you get data sets from the internet or when you scrape things from the internet, a lot of times young children are not represented, right? Also, a lot of times you should probably not try to recognize the gender of really young children because it's not, many times it's not possible, right? So again, we can give very simple guidelines. And again, are there disclaimers? You shouldn't use this for high stakes scenarios such as determining who should be a criminal because we haven't tested on that. That's a disclaimer. In electronics, you have disclaimers. They say, you know, this component, disclaimers, I don't know if you should use it on nuclear power plants or life support systems and things of this nature, right? So we have these kinds of disclaimers in data sheets. Yes?
How do you argue against the VP who just wants to make a name?
The VP?
Yeah, like, for example, if I'm a VP at a company, I see like, oh, this company has an amazing API that does this, but I want to use it in this scenario, which is a scenario, for example, like you're talking about, like,
Yeah.
possible in field analysis.
It's in the challenges in future work section. I'm just joking. No, seriously, I was going to talk about. So I think this is the challenge, right? So part of the things we have to think about, how did, for example, data sheets in electronics become a standard? Because things, you know, it's much worse of a PR disaster to have a component that's burning or whatever, like very publicly, than it is to have a data sheet, right? So, in security, I think Hannah Wallach gives this example, which is great. In the security industry, a lot of times when people had security failures, they didn't want to, or breaches, they wanted to keep it under wraps until it became more standard to just disclose right away and fix it, right? So I think that, in my opinion, like, so for example, these issues of bias and things like this, they had gotten some press in the past, so that it became not a good thing for the company to ignore it. And one of the easiest ways to start addressing the problem is documentation, right? So, but what you want to can and cannot document is a different story, right? Let's say, you know, company A wants to give characteristics about the data set that things were trained on, but company B has a much larger data set. So you don't want to say our model was trained on X number of people because company B's data set might be larger or something like that, right? So maybe then you can just disclose the distribution, certain distributions and things like this. So, you know, that's, I don't really know the entire answer to that, but I think, you know, like PR is is something that could help. And I think in academia, we could encourage these kinds of things, you know, in publications and things like that. Like, how do you encourage reproducibility? How do you encourage, you know, in many conferences, it's harder to publish a paper. I don't even know if you can do it really at CVPR. Like a lot of people's papers, you know, reviewers will come and say, well, the data set is not public, right? So in academia, we could also start encouraging people to have data sheets. For data sets, actually, there's like 3 data sets that I saw that have now data sheets, which makes me happy, when they're releasing their projects. So I think, I don't know, we can try to move that field. The field as a whole has to move towards it. I don't think it can be like individual players. Okay, so again, I was just talking about like, you might want to have a distribution of age, skin types, et cetera, if it's a human-centric data set. So we have a paper with Jamie and other people called Datasheets for Datasets. If you're interested in more like fleshing out this idea about what kinds of questions we should ask, there's different sections, and so you can check it out. Okay, and also it turns out a lot of different people are sort of thinking about this idea, even though we're coming at it from a different perspective. Like, we're coming at it from a perspective of, what did we see? Like, okay, in hardware there's data sheets, etc. There's other people who have a paper called the data nutritional label. So they're thinking of it as food, and there's nutrition labels for food. There are people in NLP thinking that there should be, so concurrently it turns out all of us kind of were like, we need to have this thing. So a lot of people are thinking about this. So, okay, again, yeah, this comes back to your question. Companies might not want to disclose certain things, and how do we incentivize the field? I already talked about it. So to close, I want to talk about just other things we know about cars. We know about cars. In the US, when cars first came on the road, there were no laws. There was no stop signs. You can be a 10-year-old probably and drive, or no driver's licenses. There's no drunk driving laws. And a lot of tests of safety tests, not a lot, all safety tests basically, were done on dummies with prototypical male characteristics, adult male, right? So then people found that a lot of car crashes, women sustained, and children sustained a lot more injuries than adult men, right? And it took a long time in the US to specify that your crash test dummies should be representative of different physical characteristics, which gets back to data, right? And similarly, this is my favorite thing. There was a court opinion asking whether the automobile was inherently evil. And judges wrote on it and stuff. And doesn't that remind you of the current conversation about AI? It's is it inherently evil? Is it going to kill us all, etc.? So sometimes I think it's fun to look at conversations people were having on other transformative industries. Another really important one is clinical trials, which Jamie knows a lot about because she did a lot of reading for this. So clinical trials first, there were a lot of illegal experimentation on vulnerable people, right? Slaves, doctors were experimenting, gynecologists were experimenting on slaves with no pain medication or anything like that. Soldiers, right? Prisoners, et cetera, right? So there's a tension, right? You have to experiment somehow to develop a drug, but you also don't want to exploit people, right? When you're developing a drug. So actually, clinical trials were illegal in the U.S. until a certain point, and once they became legal, again, there was no requirement of who should participate in your clinical trial before it was deemed okay to release the drug, right? So a lot of times women did not participate in clinical trials, and I just saw a Newsweek article that talked about how the genomic revolution is going to fly over Africa one more time, because 99% of genes that are being studied have no people of African descent, even though Africa has the most genetic diversity, right? Because, I don't want to get into the reasons for that, but the most genetic diversity. And so this could actually help advance research, but the other issue is you're not going to create drugs that will not work on a large group of population of the world. So because of this, again, lack of data, representative data to test your drugs on, 8 out of 10 drugs, studies show that 8 out of 10 drugs that were pulled from circulation between 1997 and 2001 disproportionately affected women, negatively affected women. So the whole point is that, we should draw parallels from other things that have happened and are happening, and it took many years for standards to be placed and for people to, like for example, make sure that there were representative people in clinical trials and car crash tests, et cetera, et cetera. So basically what I'm trying to say is that we should learn from other industries, and that sometimes it's good to kind of zoom out and think about things in a more big picture. What are the effects of things we're building? What are happening? Kind of questions. Sometimes it's good for us to kind of think about that, and it's not all about equations and algorithms and things like that. Cool. So I'll take more questions if you have it.
Do you know what the distributions were of any of the data sets that were being used by these companies? I guess my question is, were they representative of sort of the American population, or were minorities very heavily underrepresented? And if minorities were at least sort of represented according to like the distribution of like the U.S. population or something like that, would an algorithm still perform well, even if like they weren't in this case, or would you still need to overrepresent minorities in this situation?
So this is a very good question, right? So the first thing I'm advocating for is to understand that data, right? So if I, as an insider, I do have some knowledge because I was working at Microsoft Research at the time, so I have some knowledge of the data. But that's proprietary, so I can't really talk much about it. But what I'm saying is that when let's say I get the API from Microsoft, I should have that information. I should have information saying this, what we were trying to do, so that's the data sheet part, right? What we were trying to do when we gathered this data set is to represent the American population. So then I know. Or what we were trying to do is to represent everyone in the world between 25 and 35, right? Then I know. So then I can make a decision about, like, do I need additional data sets? Is this, to train the model, can I even use it, or for this task, etc. Right now, you don't know any of that. You have a black box of a model, and it's just given to you to use for anything, right? And that sounds crazy to me. In terms of like overrepresentation, underrepresentation, I think there's different ways. In statistics, people they do a whole bunch of stuff, weighting and there's like all sorts of things that are proposed to kind of look at, to take into account an imbalance in data sets, and also not just that, but the metric you should be optimizing for. Is it okay to have 99% accuracy on certain groups of people versus and then 20% accuracy in other groups of people? Is it okay to have a model that does that? Or should you train a model to have 60% accuracy on everybody? This is still there's different metrics that people propose, constraints that people propose that optimize different fairness metrics, right? But I honestly believe that, I don't know, I'm just thinking high level, big picture here. It feels weird to me that in order to be able to classify someone who's 5 years old or something in some manner, that I just, I'll have a very difficult time unless I see that kind of data in my training data. I think that's a limitation of the algorithms we've developed and the approaches we're taking, which is, I guess Judea Pearl talked about how neural networks have shown a lot of advancements, but we don't really know causalities, just curve fitting, things like this, right? So I think there's an opportunity to have more reasoning and inject some more knowledge or something like that, rather than what we seem to be doing right now. Okay, we'll go back and then we go here.
I heard a talk recently from Emily Bender, who was talking about something similar.
Yes, data statements, that's from Emily Bender.
Okay, right, so this is very much the same direction. I just wanted to sort of see if you're aware of that and if it was
Yes,
similar.
definitely very aware of it. I guess, it is her, I think now it's accepted to a journal, but when we cited her paper, it was anonymously submitted to open review. But we, yeah, we've talked to her and stuff. Yeah, but she's an NLP, and so her ideas were from that perspective. So that's what I mean. Like we're all kind of thinking we need this thing, but though. And then my friend Karina, she's thinking about it from chemistry perspective. I guess it's like hazardous materials, or I don't know anything about chemistry. So we're all kind of thinking like we need something like this, but we're approaching it from different directions. Yeah.
So it's not just a data issue; it's also societal bias too.
Yes.
Are you looking at an interdisciplinary approach to this? And are you talking with other disciplines about your research and how it fits into social research and other things like that?
Well, yes. In fact, Jamie can tell you more about our conference, which is going to be in Atlanta, right?
Yeah. There will be a more general, not general audience, but like people who think about fairness in many contexts, not just in a machine learning or CS conference, which will be taking place in January this year. So.
Yeah, so it's very important to have an interdisciplinary approach to this, which is like my whole thing, right? Like, because you have to talk to people who understand a particular domain. And I would say this is not just in the bias, machine learning, etc. context. I think this is useful in any context when we're working on another paper I like is Machine Learning That Matters by Carrie Weinberger? I forgot her name. Apparently it was a controversial keynote at ICML. But I couldn't find her keynote, but there's her paper. And so she talks about the shortcomings of the way we're doing research right now, the way we're evaluating research, right? We are like optimizing 1% on this data set, metrics, but like what does this 1% mean in which context, but my paper might not get accepted if I don't show, so she talks about some of these things, and I think it's really important to work with legal experts, for example, this disparate impact. Some of the ideas in machine learning fairness are coming from the legal domain, right? And like the book by Virginia Eubanks that I mentioned, which is Automated Inequality, she's worked she's been a social, an activist for a long time, and she knows a lot about poverty. She has a lot of data and historical perspective about how poor people were treated in the United States. There were these things called poor houses and things like which I didn't know about. And she knows a lot about how, like right now, some of these automated tools are unfairly affecting certain groups of people. She's done interviews with them, and she has a lot of insight, right? So we should be working with people like her to say, what should we do? Because some people say, you can't just have an algorithm and optimize, for fairness and then you're good. Sometimes you shouldn't have this algorithm being used in this particular context. And also sometimes the goal of the algorithm should be different maybe. It should be to figure out what kind of intervention you should take or something like that. Maybe not to classify someone with a probability of you're 50% likely to commit crime again or something like that. So we can go and solve a completely wrong problem and just go off here and optimize the wrong thing without talking to all these other people. I think, okay, yes.
I just wanted to add what you just said. Machine learning is not creating a new problem. It's just merely making evident the need to solve an existing one. And as long as we continue to be biased towards profit and personal bias as well, we will need initiatives like yours that translate into policy.
Yeah, exactly, which is why we, so one good thing I saw is in California, they're starting to pass a law to regulate face recognition systems use in law enforcement, right? So a lot of the issues is also people I personally did not know what it's being used for or when. Every day a new thing pops up that I find out about, right? And I think that's an issue too. I had no idea about HireView until a couple of months ago, and they're being used internationally by 600 people to figure out who's going to get a job. That seems like something serious, right? So yeah. You had a question? Someone in the back had a question? Yeah.
So to take a specific example, you had the resumes at the beginning where there was like a softball captain and a football player. One was a white male, one was a black female. So like humans also have these biases, right? So
Yeah, this is a really good question because some people argue, particularly I see this argument from a lot of business school people. There was even like a Harvard Review article saying that these one thing that I don't like the term is they say humans are noisy. And and yeah, because we're complicated. Humans are complicated, right? I wouldn't say noisy. And so then they say that a lot of times these algorithms, they have less bias because humans are noisy. So actually, higher view, what it says is that you can, they say that actually people who use them were able to have more diverse groups of people. They were able to hire people with more diversity, is what they said. Because they said they removed the human bias. That's their claim, like we don't know. So I think this is a complicated question because I believe that you are right. Like there might be cases where an algorithm can help show you your bias, maybe. Or maybe there might be cases where an algorithm is less biased in a particular way. But my issue is that without studying any of that, without pinpointing it, without quantifying it, or anything like this, we're using one algorithm to one company or whatever to do many things, right? So you might have had, thousands of recruiters in different and now distributed, right? Like in different countries and different whatever, looking at different resumes. So maybe my bias will be different here, your bias might be different there. And now if we replace all of them with this one algorithm, maybe it's fine, but it's biased in this one way, and then everybody's going to be affected, right? So I'm not opposed to algorithms in general, right? Like I'm in this field, but I'm just saying that we need to be cautious, and we need to do testing, and we need to have documentation, and we need to have regulations to figure out what characteristics something should have to be used for something else, or for a particular task. I think there were, yeah, sure.
So, getting back to the VP question earlier, so say I'm a product developer and I know within my particular field, within the particular product that I'm trying to develop, what the requirements are to ensure fairness. So I express, with higher view, I'm looking at the Equal Opportunity Act, et cetera. But then I'm purchasing some AI product from somebody else. What have you seen, or what would you recommend, seen in terms of recommendations, for how to go through the process of in-house test and evaluation to verify that these kind of, in the past had been more soft, we just have to be fair. Okay, well, I'll remember to be fair when I'm doing the hiring process today.
Yeah.
And then actually evaluating that in terms of what is the automated process doing here?
Yeah. For example, what you're asking is, I said that there is a data sheet for a resistor with various tests and various kind of performance characteristics. What are those tests in this case, right? If it's a data set, then we wrote, the paper we wrote was outlining the questions you should ask and the things you should measure for a data set. And the question is for a model for a API, what would it be?
Oh, really the question is since right now we're still in the early stages, we don't have the data sheets yet. The data sheets are coming in the next 10 years.
Oh, you're building it yourself?
Yeah, let's say that right now I am in the company, and I don't have the data sheet yet.
Yeah, so I think that this is a complicated question, and we wrote a paper about it. That's not published yet, but basically, let's say for very simple questions, right? For if it's a human-centric thing, right? What are the false positive, false negative rates for different groups of people? That's already a very complicated question. And then it's what does it mean to be different groups of people? I think so when you're doing these tests, you can start with groups that we identify in the US maybe, and then do some even simple tests like this. And then the most important thing, in my opinion, is to disclose your assumptions and what tests you have done. Because then we should never expect a model to work perfectly in every scenario for every group of people for whatever. Like what I'm advocating for is more that an understanding that that's not the case, so that people can understand which scenarios you're thinking about, what are the tests that you did. I'm telling you, we don't know right now. Like for that gender classification API that I told you, my first question was, okay, what do they write in the documentation? Nothing. What model is it? We don't know. What kind of data set? We have no idea. What's the accuracy on some publicly available data set? No idea. What's the nothing, right? So I think that disclosing your assumptions and the test that you did and what use cases you're thinking about is already a pretty big step.
We're about a few minutes past the official cutoff.
Okay, maybe he can be the last one.
Sure. So I'm working on a couple of standards with IEEE, actually user recommendations are similar on AI bias and well-being and so on. But one of the concerns is you talked about uptake. Why would Microsoft or Google want to use these voluntary standards if it might expose them to liability and so on?
Yeah.
So I'm wondering, there are movements of corporate social responsibility and people like yourself who care about ethical design.
Yeah.
Do you see those trends as making a difference in the corporate culture and decisions, or is it still mostly responsive to lawsuits and bad press?
I know that at Microsoft they were very interested in having data sheets, and I know the same at Google. Because I guess like for us, we came up with this idea because from an engineering perspective, we think it is useful for engineers. The worst thing to do to engineers, I think, is like, or other people who are in a product cycle, right? Like research is very different, when I was an engineer and I come back to research, I thought it was like maybe lost time because it's in a completely different field, but now I'm thinking, it's good to have that into understanding of when people are in a product cycle and how things go, etc., right? It's different in research. So the worst thing to do is go to some person and be like, hey, you can't ship your product because it's not fair. What does that mean? What's the process? What tests do I do? But this is kind of like already coming from, like for example, data sheets are things that are already used within a product cycle in engineering before you release a product, right? And it's also something that actually is good internally for companies, because a lot of times what happens is different teams and companies share data. Like you use it for this thing, somebody else has used it for this other thing, but they don't really talk about, they don't know the characteristics of the data, who gathered it for what was the original use case. And so that is also helpful for like internal teams to communicate. So what I've seen is a lot of people in the industry interested in it, including like startups and things like this. All right.
Should we thank the speaker? Thanks for the really interesting.
Thank you.